So on behalf of IBM and DXC, I'm Terry Roop. I'm the CTO for DXC's banking and capital markets products. In that portfolio of products is clearly Hogan. And many of you who are on the line today are very, very familiar with Hogan legacy platform that's been running on the mainframe very reliably for a very, very long time. What we want to talk to you about today is the partnership that IBM and DXC have and how we've evolved that partnership and jointly developing tools and connectors to help you as Hogan clients with some of the challenges that you're facing in terms of staffing and critical skill sets that are very, very highly in demand, but very scarce and hard to find. So what this webinar is fixated on is talking to you about a discovery tool that will help you scan through your code, as well as APIs that we're going to be providing quite natively to help you with that bottom tier of APIs that are closest to the core, so that you can focus your energies a bit more on channel-related functionality that changes more frequently. So I think that Arun is probably running our slide deck this morning. I've already spoken through most of slide 1, actually slide 2, Arun. So Arun Sharma and Rajesh and Simon Jennings from IBM. Arun Sharma and Rajesh are from DXC, Simon Jennings from IBM. They're going to be taking over. One more slide, please. They're going to be taking over in just a moment. If we could go to slide 3, please. Okay, very well. So, you know, what we are going to be talking about today, again, is the tools that will help you do modernization in place of what has been a classic mainframe delivery model. And there have been several very notable advantages to this delivery model over the years, including the likes of scale and reliability, but it's not without its complexity. So that said, we fully believe that the mainframe model remains extremely viable for high demand clients, but we've jointly embarked on developing a set of tools to facilitate modernization in place while externalizing some of the classic customizations that have been done to the Hogan platform itself, and migrating those to a new operational tier, if you will. So in that vein, I like to think of Hogan in the same sense of an aircraft carrier, if you will. You know, they're both extremely stable platforms that have served very, very well for decades, not because they're naturally agile or easily reconfigured historically, but because they're a very, very stable platform to launch from and return to. So I believe that just like an aircraft carrier, Hogan and the mainframe becomes quite lethal because of the tooling that we've evolved and we're going to talk to you about over the remainder of this hour. The tooling that gives you new launch capabilities and new ability to make change at a more rapid rate. So without any further delays, I'm going to pass the baton to my colleague Arun Sharma. Arun, please feel free.
Thank you, Terry, and welcome to everybody on the call. So, as Terry has mentioned, that the Hogan has served us in the last many years, and it has proven as a very, very stable environment to launch mission-critical application, core banking applications worldwide. So, on this particular thing, right now what we are seeing is that the Hogan picture, overall Hogan picture that many of us are aware about. The Hogan core banking application has power and potential and has served well. Needless to say that it is highly scalable, extremely reliable, and a highly customizable application. So out of the box, you have an option to customize to your needs. It runs with the flexibility of a standard set of technologies such as COBOL, JCL, and DB2. But as the Hogan community and the Hogan users know, that we do speak a little different COBOL than the rest of the COBOL world knows. We call something PAM, we call activities, we call data groups and other things, as those terms are unheard of outside the Hogan realm. When it comes to the application analysis and understanding, there is a powerful mainframe-based cross-references facility which is delivered as part of the Hogan application itself, and they are consistent across multiple applications. But as we all know that outside the mainframe, there is nothing that can give us a visual representation of our application construct, how they're constructed together, what is our application repository looks like, and how they are interrelated to each other. Hogan programmer over a period of time has figured out multiple ways to find out that cross-references, to find out the drilling down capability inside the Hogan application. But as the time passes, some of these knowledge and some of these skills are slowly become not available anymore because of the aging workforce and other things. And we are finding it as a challenging situation that we do not have any more any off the mainframe analysis tools, or most of the organizations suffer from a poor documentation. Whatever the analysis tool is available on the mainframe, they are non-visual in nature, and typically developers, architects, or business analysts have to create a lot of cross-references to build a complete picture of an application construct or even a function construct. We do not supply an out-of-the-box analysis report from Hogan, and Hogan application analysis, even though some of the cross-references tools are powerful enough, they are limited to only Hogan application. So some of these challenges as a developer that I have faced over a period of a time, and I'm sure that most of the Hogan developers have been facing this thing, that is there a way by which we could see Hogan application, full view of a Hogan application. Today, we have solved that particular issue. Now, when we have solved that issue, we have also now been engaged about bringing Hogan to a newer world. As the Hogan mainframe has becoming a core central system of the application of the bank, now the API economy has been taken over the world, and everybody is talking about API. So again, Hogan system does provide some connectivity option and is always part of the API economy, even though the word API sounds new, but API was always there. And we always had in the past the multiple integration options, including legacy and the modern. So for an example, we had SAS and SUA options available out of the Hogan. But as the time passes, the functional depth and the backlogs are mounting, that because we are not able to expose all of our application in time and in need from the market demand. So the data demands are increasing, the market demands are increasing, and the agility by which these Hogan applications have to be exposed outside the Hogan box is increasing day by day. And of course, an enterprise cannot leave Hogan application behind when they're talking about a complete enterprise architected solution. So in summary, we are today talking about two major challenges and two solutions. One is around looking or drilling down capability inside the Hogan application, and the second one is to bring the API economy to the Hogan system. Move on to the next slide, please. And I would invite Simon Jennings. He's our IBM partner, and he is going to talk about and give a little bit brief about IBM application discovery and delivery intelligence. Simon?
Thank you, Arun. Can you hear me all right?
Yes.
Great. Hello, everybody. So great to have the opportunity to be part of this. Some of you may indeed, as customers, already have ADDI. Some of you may have deployed it, and obviously some it will be a new platform. But essentially, ADDI is IBM's platform for mainframe application analysis across any mainframe application. And the other mainframe product that you're going to hear shortly is called ZOS Connect, which is an API building product. And essentially, both of these products work in tandem So in this context, ADDI will work to help enablement and accelerate the implementation of APIs. But it's also used in customers for any sort of change activity across the mainframe. And the reality is that, the amount of expert level knowledge has decreased, and obviously the applications including Hogan are fairly large and complex. So being able to make any sort of change activity is a very time-consuming task. So what ADDI does automatically from your source code is allow you to do a whole variety of tasks, sort of visually report-based. So to start with, being able to sort of unlock the value by giving you application structures and impact analysis, interdependencies between all of the components such as source code, JCL, database, copybooks, et cetera, and allow you to sort of have a high-level view at an application level, and indeed help you define your application boundaries and interfaces, but drill down right the way into sort of program structures and database relationships as well. Certainly what we're aiming to do is help you bring in this as a key component as part of a DevOps strategy as well, with other components like IDEs being able to really accelerate and empower your teams to be able to sort of deliver API and digital projects much faster, and being able to actually modernize your core business logic. And for one of that thing on the last praise column is there's some great understanding functionality about being able to identify business rules, for example, to be able to identify components. So you can actually, for the first time, really identify all of the components that are there as part of your key logic. And the final thing to leave you with is ADDI is a fully automated product that you don't need any manual intervention to help in the building of this because of automated connections through your source code platform and also the integral parsers that have the knowledge to build the model, as it were. Thank you, Arun. Back to you.
Thank you, Simon. So once we, let's move on to the next slide. So as Simon has said, that ADDI empowers a bank and its technology staff to look into the application as a whole, construct about how the application repository is, what are the major components inside the whole application is. But when it comes to the Hogan application, suddenly what happens is that ADDI draws a little blank, primarily because, as I was mentioning in the previous slide, that the Hogan construct is very different than typical COBOL applications. So while ADDI was able to penetrate inside the COBOL programs, it was not able to create interdependencies and the relationship between the COBOL programs and the Hogan COBOL programs, primarily because everything that we do by a layer of PEM, as everyone of us know who has been working on the Hogan system, that the PEM is the commander-in-chief of Hogan application, and anything and everything that we would like to get it done through Hogan application, we pass the control to the PEM system. Then can we move on to the next slide, please? Then can we move on to the next slide, please?
Yes, I did. Just a moment, please.
Sorry. So the point I am making over here is that when we started integrating Hogan application with the application discovery and delivery intelligence, we immediately find ourselves into a kind of a situation where we have to find out a way to look into the Hogan application. That's where we converted or we created what we call it as the Hogan ADDI connector. Simon, oh, sorry. Darren, can you move on to the next slide, please?
There you go. I'm still on slide number 4. Okay. So on this particular slide,
The reason that we have created this Hogan ADDI connector is to primarily support the CDMF. So as all of us know that all the Hogan application is driven by the process dictionary construct, and process dictionary construct has many different variables when it comes to constructing an Hogan application, such as all our programs are linked via an activity, all our transaction definitions, map definitions, and SPS and everything is linked via an activity. And for applications such as ADDI, an activity is a concept which is not known to them until unless we create this connector or until unless we teach ADDI to also talk the Hogan language. We also, as we know that Hogan programs, they are very much interrelated to each other through an activity call. So what we have created as part of this Hogan CAMS2 connector for ADDI is that we have used the power of ADDI to also extend the powerful visualization on the Hogan application. Now, probably the question that comes to everybody's mind is that what is the process? How do we actually do that? So the process of doing that is that we extract all the Hogan source code such as program, JCLs, and copybook from variety of our source control manager tools through the extraction mechanism, which is out of the box from ADDI, and then we enrich all of this information through our Hogan ADDI connector, which will get you the information about all the CDMF, all the process dictionary constructs, and then Hogan ADDI connector also enable to scan through Hogan programs inside ADDI to convert the activity calls into its proper definition. So when I say proper definition, that an activity call inside a program may call another program through a PAM call, and we translate all this PAM call into a proper program definitions and as well as map, SPS, and FPS definition. What we have noticed that once we enable the Hogan ADDI connector, we suddenly have a lot of power in hand, especially around the impact analysis. So ADDI does provide out of the box where use reports, and then we have like where are the copybooks used inside the program, what are the variables which are used inside the program, and if you touch any variable, what is the impact of those variables in the rest of the ecosystem. Once the Hogan ADDI adapter was enabled, then the same impact analysis power was extended onto the Hogan copybooks, Hogan files, and the JCLs. So in summary, the picture that you are seeing below is now we have an enterprise level power with the Hogan ADDI connector by which you can connect Hogan and a CAMS application inside the ADDI powerful visualization tool that we are also going to demonstrate in a few seconds, as well as other ZOS applications. So now you have an enterprise-wide drilling down capability as well as the connectivity between the applications so that you have a complete picture of your enterprise ecosystem as a whole. Let's move on to the next slide. So this is just a brief introduction about the ADDI. So what the power that we have exercised through the ADDI connector. And I would invite Rajneesh Bharwal, my colleague, to talk about the ZOS Connect Enterprise Edition application.
Thanks, Arun. So, good day, everyone. So I will be talking about ZOS Connect and the tool which IBM has come up for generation of the system level APIs, which can expose Hogan applications to the distributed environment or the distributed application inside the bank. So, so the philosophy, I would say, behind development of ZOS Connect Enterprise Edition framework is that we wanted the API interaction from the mainframe as well as into the mainframe. So we wanted the APIs to be to ask information from the mainframe or to update information in the mainframe, and at the same time we wanted mainframe application like Hogan to inquire or invoke APIs which are outside the mainframe environment or which are in the distributed environment. Another important aspect of the philosophy behind creating this tool is that we wanted to have a comprehensive subsystem support. We wanted to cover CICS. We know there are Hogan clients who are on CICS, as well as there are Hogan clients who are on IMS databases as well as IMS DC. So we wanted to cover up all those clients, and that is the philosophy behind IBM creating ZOS Connect Enterprise Edition also, to provide maximum coverage and to ensure that we are fetching the records, or we are able to interact with the system of record applications. Last but not the least, ZOS Connect has ensured that it has provided a ZOS Connect API toolkit interface, which helps in defining the APIs with the point and click of a button. There is with the UI interface which comes out of the box with ZOS Connect Enterprise Edition. There is no need to do the coding, so all the definitions of the API and development of the API are handled by the click and point and click of a mouse. By doing all this, basically we are opening up the Hogan functionality in the form of RESTful APIs, which follows a specific standard known as a Swagger standard, or the recent name is Open API standard. And so any API management tool would be able to manage the APIs which would be built using ZOS Connect. Devin, can you move to the next slide? Thank you. So I would be talking a little about, or I would say, extend the philosophy which ZOS Connect, which IBM ZOS Connect Enterprise Edition provides to us. So DXC has come up with a solution which is known as a Hogan connector for ZOS Connect Enterprise Edition. And what we are doing with this connector is we are extending whatever functionality or feature points are provided by ZOS Connect Enterprise Edition. So basically what we are ensuring is with this connector, we are providing an infrastructure which has the ability to handle the API calls which are coming into Hogan, and also have the ability to invoke API calls which are to the applications which are outside the Hogan. And this is, I would say, the connector has been built using the existing PEM, umbrella PEM infrastructure. So it is pretty fast. We provided the capability that the connector can support large amount of data. So we have ensured that the connector is based on the CICS channel and container concept. And on the IMS side also, we are ensuring that it is supporting large data sets. So since the connector is basically nothing but a PEM extension of the Hogan PEM infrastructure, so what apart from ability to execute the API request inside and outside of mainframe, the another functionality, or I would say the feature function which this connector provides, is the ability to create the APIs using a few of the CDMF items, Hogan CDMF items, and in certain requirements you need to write a driver programs, but those are not in terms of the core application, Hogan core application driver programs. These driver programs are quite simplistic in nature. The good part is these driver programs, or the API infrastructure, the driver program which we are building, or we have the capability to build, it can invoke any of the core application programs. You don't need to replicate the functionality. It also provides an ability to add up more functionality if it is not available in the core applications like CIS, IDS, or ILP as of today. So it is more of, I would say, an extension to the existing core application which you can build, and at the same time you can expose those functionalities to the outside world as APIs. So few of the I would say the future things or the roadmap things which we are planning to do is, as of now, we are not providing the functionality outside of Hogan, like invoking an API outside. That is something which is on the roadmap. Another roadmap feature which we are planning to roll out in the near future is we are trying to make this umbrella, make the connector umbrella agnostic, umbrella version agnostic, so that there is no dependency to update the version of the umbrella for the connector to work. So here I would take a pause and we can move to the next slide. Thanks, Jayant.
Thank you, Rajesh. So basically now what we are doing is that with the introduction about the ADDI toolkit, Hogan ADDI toolkit, which enables you to do application discovery, and API enablement toolkit through US Connect Enterprise Edition, we are going to go into a small demo where we are going to use the power of both ADDI as well as US Connect Enterprise Edition. The demo scenario that we have taken is, for an example, is that a customer would like to create a new customer setup API. So as we all know that there is a customer setup is a function of our Hogan customer information system, and we would like to create a customer setup API with the ability to set up an individual or commercial customer. We would also like to provide the demographic information for the customer during the setup, and also provide the information to set up a customer with some of its account details. So in this demo scenario, what we are going to do is that we will be doing the initial analysis of what are the key constructs that we would require to build using ADDI. So we would be looking and discovering the US assets using ADDI and identifying the interface structure to create an API. Later, we will actually build that API during this demo itself using the US Connect API toolkit. And once this API toolkit is being successfully done, the powerful part of this is that any US component that you build as part of the API will automatically become the part of the repository for the ADDI. So the next time when you do the impact analysis or anything like that, the API pieces will also join the overall impact analysis team. So at this point of a time, I will move into the actual demo scenario. Darren, can you pass me the presenters, right?
Rajneesh, you have presentation control.
Darren, this is Arun. Arun would require a presenter.
Okay, just a moment, please. Rajneesh, would you please pass control to Arun? Just a moment, please.
Then I'm not able to the desktop participate.
The joys of WebEx. Just a moment.
Yeah. Darren, is there a way you can do it? I'm not able to open the panelist panel on my desktop.
No, unfortunately, I've got Rajneesh as presenter, so unfortunately, he's going to have to be the one to return the ball. All right. So, Arun, you should now have host privileges.
Still can't see that option, Darren. Sorry about that.
Okay, just a moment, please.
Sorry, everybody. But in the meanwhile, while we are trying to get now I get the power as I call it. So let me share my screen and get started with the demo aspect. So you should be able to see my screen, and I will straightforward jump into the ADDI demo itself. So let me know, Rajneesh, can you confirm you are able to see my screen?
Yes, Arun, I am able to see your screen.
Okay. So sorry about the delay. So basically, there are certain technologies which is beyond our control, but at least there are things which is in our control, which includes this demo as well as this ADDI connector. So what you are seeing right now is an ADDI panel. This is an Eclipse-based application, and it comes out of the box with a lot of features. So one of the major features about this application is that you can build as many projects as you would like. A definition of a project, typical project, is a collection of your mainframe assets. Now you can create your collection of a mainframe assets per application, per environment, or a collection of an application together on an environment, or the choices are unlimited. So you can create multiple projects. Some of the use case scenario that we have seen in the industry is that you can create multiple projects, one for the dev environment, one for the test environment, one for the QA, one for the production. So at some point of a time, if you would like to create a comparison between the different environments, you have a choice to create a project such as. And you can also use the project as a baseline for your environment or a snapshot of an environment on a given day. So for this demo, I have used a very basic application discovery for Hogan project and the basic testing project. So as you can see that as I click on any one of these projects, there is a panel that appears on the right side. So the panel gives me a lot of choices immediately as soon as I start looking into the choices. So as you can see that the panel gives me annotations, API usage. So like Rajneesh was talking about, that once you construct API, it also starts talking about the API's components inside the ADDI itself. So what I'm going to do that today is that I'm going to start the demonstration with the Explore project. So Explore project is a way by which you understand that what are the programs and the copybooks, as you can see in this drop down, that what are the components of your Hogan application or a mainframe application, because this is a Hogan application demo. So what are the components which are available inside that project? So we have seen that it is right now showing there are 71 COBOL programs involved in that. And all COBOL programs has multiple copybooks involved in that. So there is 183 copybooks involved in that. Similarly, there are a lot of choices such as jobs, such as different type of a transaction, such as different type of a data sets. So when we talk about the data sets, this is a listing of the multiple data sets used inside a job. And this is just a listing, but not a cross-references. And what we're going to do is that we are going to build that cross-references now and show it to you. So I'll take an example like the customer setup API that we are going to build today. And if I were to do the same thing on a mainframe, I would have followed certain steps. So let me just quickly go through that step as a kind of a reminder that how do we typically do an analysis inside a Hogan mainframe, and then come over here in ADDI to tell you that how quickly you can get a benefit of 60–70% of a productivity gain just by use of ADDI itself. So on the screen, I'll just switch on to my mainframe view. And because we are doing a customer setup, my typical analysis starts with, let's first bring me the customer setup screen. The customer setup screen is part of my CIS application. And in the CIS application, if I type customer setup as a menu item, I get this screen itself. So this is the screen on which the fields are listed there, which I would like to use as part of my API. Now, before I build my API, or even if I have to write a COBOL program, not for an API or for any other purposes, I have to start doing analysis is that what are the programs involved inside this screen. So the SPA2 command brings me an FPS entry. So selecting that FPS entry and typing FPS, I see that this is my FPS entry, which says that there is a map involved, 64121M for this in a D block, and then there is a program involved, 64121. If I would like to further investigate this program, I'll come to the program definition, program activity, and inside the program activity, I see a lot of activities at the bottom. If I would like to see what are these activities involved and what these activities do. So this is my A64121 program. And if I have to do a cross references back of this activity, I typically start with an activity 24121, press PF2 to see that how it is being called. As we have seen, it is invoked through a FPS scenario. Now, as you have just noted that I have done a few steps, bringing customer setup screen, finding out its FPS scenario, finding out the program involved in that, finding out the maps involved in that. Now, how I can do the same thing inside the ADDI once the ADDI connector is invoked. So I go back to my demo project, and there is an option by which we call it as a view annotation. Now, what we have done is that when we were extracting our Hogan parameters from our CDMF, we had put certain intelligence around those parameters, and we enriched those parameters so that those parameters comes with some additional information. So if I have to analyze, or if I have to find out that what are the parameters or what are the constructs which are involved in a customer setup, I'll just do a wildcard search on a cust and just find out that what is the listing that comes up. This is my small project. So as you can see that it automatically comes with what it calls as the individual customer setup, which is exactly the same 24121, which I had to do 6 or 7 steps on the mainframe to find out what is my customer setup activity is. Now, once I find out what is my customer setup, this is my customer setup screen or the activity is, I have few choices on my right side panel. As you can see that I can add annotation, which is just adding some additional information to this particular information that has already been retrieved. Like this is an activity ID, so I can add a little bit more information. However, the most important information in this picture is these three: flowchart, program call graph, and program flow. So if I click on a program call graph, double click on that one, as you can see there is a multiple direction it shows. Go from the starting point as a program in a forward direction or a backward direction, and in both the directions. So for this demo purposes, I'm just picking up an option of both so that I can show you a complete infrastructure about this particular program. The label actually shows that how deep you would like to go into the analysis, and I would like to just keep it at a very high level because this is my initial understanding, and because I'm creating an API, I don't need to know at a multiple levels what's going on at the bottom most level. So I just start at the very highest level, and when I click on finish, it starts creating. You can see that it brings up the map which is involved in that, and then it creates this beautiful picture. Now you can see that in this particular picture, my COBOL program is over here. Let me increase the size a little bit over here so that you can see it. So here is my A64121 program that I have to find out through multiple steps in the mainframe, and on the ADDI, just by the do on a customer setup search, I find A64121. Notice that it is linked to the map A64121M. If I would like to see the map layout at this point of a time, just a right click will bring the map, which is exactly the same map as you would see on the screen. Now all this magic is happening because of this connector that we have built in and information that we have extracted from our CDMF source. Now the question is that good that this information is good, and there's a lot of good information. So in summary, this information, what it says is that this particular program is being invoked by multiple programs, and this program in turn invokes many programs. And there is a JCL which invokes this program also in some manner, and there are files involved in this program, and then there is a map which is used to send or receive the data inside this particular program. However, in order for me to construct an API, I need to know what is my payload that I need to pass on for this particular program. So typically an API creation task has few steps. A business analyst will tell you by looking into the map screen itself that let me just seen that this is my map screen. So business analyst might say that I need to build an API which has the information such as name line 1, name line 2, all of this information that I would need to pass on as to build my API. So typically a business analyst would start with something like this spreadsheet that you can see on this screen. He will say that, okay, I would like to build my API with all this information, name line 1, name line 2, and they are on the customer setup screen. He would stop here and he would not tell anything more beyond that. Now, how do I identify that what is the payload field involved in that is through my ADDI system. So inside the ADDI system, the process to identify the fields involved in that is that I look into this particular program and right click on this one and say what are the copybooks included in this particular program itself. So if I look into the include usage, it will tell me that these are all the copybooks inside the program. And I am just skipping certain steps of ADDI from the perspective because of the time. So inside this program, I find out there is a copybook 64121. And if I double click this copybook, which opens at the bottom side, it opens with all this information. As you can see that I was looking for the name, and here is my name too. So using the information from the ADDI without even going back to the mainframe even once, and everything all consolidated, I have collected all this information like name line 2 comes from this particular data group 24121, and the field name would be what is shown over here. So I just copy this field name and just put it into that spreadsheet. So through ADDI, I have folded multiple analysis steps into just 1 or 2 steps for analysis for creation of an API. Now, having said that, the ADDI is not only used just for the API creation. The ADDI has much more power beyond that. So there are a lot of options available inside the ADDI. And right now, because we like to show you also how to create an API, I'm skipping these options. But I just highlight some of these options that when you are looking into any particular program, you can create a program flowchart, which is extremely powerful and a useful tool, primarily because if you would like to do a re-engineering or looking into a program from a flowcharting perspective, ADDI will go inside the program and it will create a complete flowchart of how the sections are being called, what are the if then else conditions being invoked. It also gives you a lot of reports inside it. As you can see, it gives you complexity report, dat code report, inventory report, what are the pieces and the parcels inside this particular program. And it also gives you, or if you are running an IMS instances, it will give you the relationship with IMS. And it also links with you all the JCLs and the job, as you can see in this particular graph that we were looking at this point of a time. So ADDI enabled me to pull up all this information from the Hogan applications without actually going into the mainframe. Now, with all this information which is now in my fingertips, Rajneesh is going to create the actual API in the next few minutes itself. So I'm passing the control back to Rajneesh, and Rajneesh can start building the API itself.
Thanks a lot, Arun.
Go ahead, Rajneesh.
Let me know when you're able to see my screen.
Yeah, we can see Rajneesh.
Okay, so from here on, I'm going to put the developer hat and pick up where Arun has left. So Arun has provided me with the details about the fields which needs to be exposed, the Hogan CIS fields which needs to be exposed as a API payload. I know what fields needs to be are required for the input. I know which field should be part of the response payload. With this, I would start my API development. The very first thing I would do is I would update this with the Swagger fields or some fields which are meaningful to the end user, or basically the users who are not the Hogan users. The ZOS Connect connector, it provides me an option to create an API as is using the core, the fields or the copybooks which are used in the core application like Hogan CIS. But we basically recommend to create separate copybooks so that it is understandable to the ZOS Connect Enterprise Edition developers, as well as it is more easier to maintain in the future if we have all the data consolidated as single copy. So the next step which I will do over here is in my mainframe I would create a request copybook, which you can see on the screen as of now, and similarly I would also create a response copybook or the copybook which would help in defining the response payload. So once I have defined the copybook, the next step or which I would do is I would go into the Hogan transaction, and this is the capability, and I would say this is the strong feature of the connector which it is providing. We have extended the existing umbrella architecture or the PEM architecture to incorporate or to handle the API calls from outside. The API connector provides me with the Hogan transaction, and I have an ability to create a Hogan transaction, and from there on I can, based on the list of activities, I can drive my Hogan transaction. So some of these activities would be API container maps, debug maps, and some of them would be display maps, and some of them would be link activities or the program activities which needs to be defined for this particular API. Although the connector helps us with defining with just providing the core application activities like CIS activities here, if it is just a single screen program or screen fields which has to be exposed, but in this case, since there are multiple screens which are involved, so we have written a small driver program to handle that. So once we have defined this Hogan transaction, written a driver program, the next step I would say, I would say in parallel, since the Hogan developer would be using the copybooks, and similarly the ZOS connector, the ZOS Connect Enterprise Edition developer would be using the copybook as well as the Swagger defined fields to define the API using the API toolkit. So the screen which you see is my API toolkit perspective, where if you notice on the left hand side I can see the ZOS Connect APIs which are currently running on the server. So I have ZOS Connect server which is running inside mainframe, and I have like all these APIs which are running on the server, and then I have the services which are running on the server, which are required to run the APIs. So the next thing or the thing which the ZOS Connect developer would do is I have to go and create the API or define the API on the ZOS Connect side. Since I have created or I completed the work on the mainframe side by defining the deblock and the display activities and the driver programs. On the ZOS Connect Enterprise Edition side, I would first of all create a service project. So as I mentioned in the beginning, so this is a channel and a container-based project. Our connector supports that. I'm selecting the channel and a container-based project. So when the perspective opens up editor for service project, it shows it has 3 errors. So these are basically the mandatory things which we have to do. So I would provide the mandatory fields, for example, the program, which is the Hogan program or the gateway program into Hogan, which would be invoked when this API is invoked. There are a few other things which I quickly have to do. I have to provide the connection name I have to provide the CICS transaction which is required to execute this API. I have to create I can quickly create a service request, although there is an option to import. But I wanted to show some of the good and easy to use features of the service. So I would create a quick service interface here. So basically I have to create a request interface as well as a response interface. This what I'm creating here is my request interface. I have the channel, I have the container. I would update the channel name to make it more understandable that this is for create customer. I'm updating this, updating the container which would contain my metadata, the data which would help in defining what Hogan transaction, the one which we were just looking on the Hogan mainframe screen, has to be invoked via this API. And I would also add another container which is a request container for this API. Once I have created these two containers, what I would do is I would just I have already imported the copybooks on my system. I would go and attach those copybooks to these containers here, so this is my request copybook, which I'm attaching with this container. Once I have done that, now you can see we have all the fields available here on the interface. Over here I have an option whether I want to show these fields to the end user of the API, or I can hide all these fields which I don't want to show. Like for example, there would be a lot of control fields which I would not like to show to the end user. So I would what I would do is I would hide all those fields. Some of the fields which I would require, for example, I want to show the transaction, the Hogan transaction which has to be invoked. I would provide that Hogan transaction default value here, just selecting for the fields which needs to be shown. Then there are certain control fields which are for sure required. Since we are handling multiple containers here, so it is basically two containers which we are handling here, I would provide those container names, quickly provide the name of that container. For example, we are using a request container, and the type of the request container is input into mainframe or input into Hogan. And similarly, I would quickly define the response container name, which is making it simple, so it's response, and it is an output type of a container, so we used to send the data outside of mainframe. So once I have done this, that is it. My my definition for request is ready. I would save it.
Rajnish, in the interest of everybody's time, we have 3 minutes over the webinar time. Probably we might just want to wrap it up quickly so that we can have some time for question and answer.
Yeah, I would skip few of the things quickly and show the end result. So this is where I am creating the request and the service request and the service response. I have few options which I can perform, like for example, initialize the field. Against that, once it is done, my service is ready. I do not have time to create the response, but we have to create the response, and this completes one of the projects which is required. So once I have completed this project, next thing which needs to be done is I would create an API project. I would give some name to the API project, and it would open up a new perspective for me, where or an editor, where I can choose which HTTP methods have to be selected for an API. And I have the option here to select the service, which I just created few minutes back, and which is basically a mapping into the Hogan mainframe COBOL copybooks. So once I have done this, a very easy execution. I would just go here on the left hand side, do a deployment of the service. Similarly, I would do a deployment of an API. So on the left hand side, if you see, we can deploy the API. So once I do perform both these tasks, the API would be deployed on the server. I already have an API created. What I would do is now I have created the API using JS Connect easy to use interface. I have deployed the APIs on the server using the same interface. Now I am going to test it. So Swagger, JS Connect Enterprise Edition provides me the Swagger with the Swagger test console, which I can open up to execute the API. So it has opened up the Swagger console. I can see all the fields which I have created. The request interface and the request response interface. It shows me what values has to be inputted. What I would quickly do is I've created a macro to update the fields. So it has updated the data for me. What I'm going to do is I'm going to create a customer Sam Jones. It is an individual customer. I'm using tie 8. The customer provided all the required data and other data like what kind of business relationship is that customer is having with the bank. I have provided the remarks, and I have also provided the address which I want to attach to this customer. So once this all is done, I will provide the basic authorization key, and that is done. So I would this is all the data which I have to put in. Just before doing this, I just want to show on the mainframe side. If I do a CUPR and try to search the customer on the mainframe screen with a tie 8, so it does not show me that customer. So I'm going back. I'm going to execute the API. So the API has executed. It shows me the successful. Execution of the API. I'm getting a successful response. All these fields has been added, so I can see the response fields on the screen. So this is on the test console. Now, if I go back on the mainframe screen and try to search this customer, so now I have all the data which I added via an API on this customer. So all the data is added into the Hogan database, and so the customer has been set up. So with this, I complete my API demo, and I give the control back.
Yeah. Thank you, Rajneesh. So we